This is my Forces in Circular Motion Reassessment, Chapter 5. I chose problem 41. A pendulum is 0.80 meters long and the bob has a mass of 1 kilogram. At the bottom of its swing, the bob speed is 1.6 meters per second. What is the tension in the string at the bottom of the swing? And explain why the tension is greater than the weight of the bob. So, to start out, list what you know. 0.80 meters is the length of the swing. Is the length of the string, so that means 0.4 meters is its radius. 1 kilogram is equal to the mass of the bob, and then the bob moves at 1.6 meters per second, and that's its velocity. So you come over here, and the summation of the radial forces is equal to tension minus mg, or mass times gravity, is equal to mass times radial acceleration. So you add mg to both sides, t equals mg plus mar, and then you factor out an m, t is equal to m, open parentheses, g plus ar, gravity plus radial acceleration. So ar, as you can see here, radial acceleration is equal to velocity squared over r. So you plug that in because you have velocity given. It's also equal to omega squared r, but since we don't have an omega, we don't use that one. So we come over here, t is equal to mass times gravity plus radial acceleration, or velocity squared over r. T is equal to 1 kilogram, the mass of the bob, times 9.8 meters per second squared, which is gravity, which is the g, plus 1.6 squared, because that's the velocity, and then 0.4, which is the radius. And that comes out to your tension being 16.2 newtons. And why the tension is greater than the weight of the bob? If the bob was at rest, then the bob and the tension would be equal. But because the bob has an upward acceleration, the net force must be upward and greater than the bob, which would mean the tension is greater than the bob.